Hello, we're going to review a simple class. Recall what I'm using here, different from our classroom, is instead of co-blocks, I'm using the Microsoft Visual Studio. You can download this yourself on the internet. Here I have my Solution Explorer, that's our file manager. I have the source files, I have resource files, headers, external dependencies. The only thing we're concerned with here is source files, and there's my main program will be in, that's my main method, will be in source.cpp. So I'll start this off. I'm going to increase my screen size even further to say 175. I thought I put down 175 there. Oh, what the heck, 200. Include you see it looks a little different than what we use in class. But the same ideas are there. My typing is still terrible. I'm going to create a simple main program that deals with 2 points. And I'll make them global for now. I'll use integers, integer x and y. And I'll call that x1, y1. And I'll have integer x2, y2. Now if I want to use them in my main program, I can say x1 equals 0, and I can say y1 equals 2. I'm only writing them on the same line to make it look nice. x2 equals, say, 5, and arbitrarily picking y2 equals 9. Arbitrary points. And I'd like to do things with these points. I'd like to be able to see if they're equal. So I'll call this one point 1, point 2. I have a lot of work to do here the way it's done. I have these two variables, x1 and y1, and the two variables x2 and y2, and it's up to me to keep them together. And that's a lot of work. Wouldn't it be great if, and this is what we will do, I could glue them together and create my own variable. For example, a keyword class. I'll call the variable point, P-O-I-N-T. And now I have this object here, this object called point, and it has two variables inside it, x1 and y1. I don't have to say x1 and y1 anymore. You'll see why. In my main program now, I can do things like point A, B, C, and each one of these points will have its own x and y values. Now, we talked about wrapper code and encapsulation. With this object, I would like to protect these variables. So to protect them, I will make them private, the new keyword we discussed. Private. Normally, because of the idea of encapsulation and the like, I want to always protect things. So by default, everything is private. If I want to change x or y or get access to them, if I go down to the main, I type a dot x equals 0, the compiler is going to be a tad upset. If you look under my cursor, you will see it says private, because anything inside a class is automatically private. So what I can do is make them public. Drop the protection. So now you see it is not complaining. I can say a dot y equals 2. I can have a lot of fun now. I don't have to remember 1s and 2s. I can say b dot x equals 3 and b dot y equals 10. To avoid typing a lot, I'm just going to use two variables. Now I like this idea that I can encapsulate a lot of things in here. For example, I could put a third variable in there. I can even put another variable, Boolean, to tell you if true or false, should you let me see this point? And I might call the variable hidden. And it'll say whether or not X, Y, and Z should be hidden. I could have another variable, integer, the red color. What is the red, green, and blue color amount of this point? So it's a pixel on the screen. The pixel on a two-dimensional screen, such as the one in front of us, has an X and a Y position. And can I see the dot, or is the point invisible? And if it is visible, what mixture of colors do I use to create these points here that are sort of gold, the white colored points, the black points, the blue points, the green points, these pixels? Now we're not going to get into something so deep, but it's just to show you that I can have as many variables as I want with the idea of creating this object called a point. I'm going to stick with X and Y at the moment. And I like what I have so far. But I don't like doing this. This looks like a lot of work to set up the data. Wouldn't it be great if I could say X is 0, 2, so I don't have to type this entire line? That's a lot of work typing this line here. And I'm prone to make mistakes. So in order for me to do this, I have to tell the class point, I have to give it an initializer. This is called a constructor. And it must be public. The constructor has the same name as the point. So I say point, and I want to give it two numbers. So I want to give a point, because A is a point, two numbers. All right? I want it to be integers. Integer A, integer B. And I want to take those integers. I'm going to take the integer A, and I want to move a copy of it into X. And I want to take integer B and move a copy of it into Y. So now I have this ability to move numbers in there. Now I was complaining about B, because B looks like this to the compiler. I gave it nothing. So what I need to do with B to have that work now, as I say point, if you give it no data, this is what I want you to do. I want X to equal 0, and I want X to equal Y equals 0. I thought I'd do that in a shortcut. So now I have my X and Y, but no one's protecting them. So I'm going to get them out of here. I'm going to move them right up there into this private area. And I don't have to, but I like writing private. It reminds me that X and Y are private variables. And I can set them here, but now I cannot do this. This once again becomes verboten because it's private. So how do I get to X and Y? How do I change them if I want to change their values? I want to make it immutable. Right now it's immutable. This point cannot change. Point A must always be 0, 2. Point B must always be 0, 0. If I have a point C and I make it 8, 9, 8, 9, it can never change. Because I do not have access to changing this. I can only create it with these constructors. Sometimes abbreviated CTOR for constructors. Well, now to make some changes. I would like to be able to change X and Y. To do that, I can write a function inside point, and they're called getters and setters. So I might want to set X. So I like using the letter A, get the letter A, and put a copy of A into X. And I'll do the same thing with Y. I'll say set Y. I like the letter A. It's only a dummy variable, so I'll use it again. And I can say Y equals A. So down here in my main program now, I have something more powerful. I can say A dot set X. So I can change X equal to 4. Right there, X is now equal to 4. But what if I want to get X out? I want to see what X is. So remember, X and Y are locked away in this private section. So what I can do is now create a getter. So I can say it's an integer. Give me back an integer. I'm going to use the word get. Why am I using the word get and set? Because everybody pretty much uses get and set to mean get your variable and set it. So if I'm going to get X, I don't have to give it any data. I simply say return a copy of the value of X. The same for Y. Get Y. Return a copy of the value Y. I'm being very careful in my language to say get a copy of the value, because I'm really not giving you this Y and this X. If X is the number 6, this will return a copy of the number 6 to your main program. You won't get the actual number 6. I'm not going to let you touch the actual X or Y. There are ways to actually touching the X and Y, and it's dangerous, and we can talk about that later. So now I could do things like this. Cout. I could say point A is A dot get X. And I'll put a comma there and show me Y. A dot get Y. And so things look nice. I'll have it skip a line. If I build and run this program, you can take a look and you see that I have point A, B, and C. I'm not using B. I'm not using C. The computer is not going to complain. Well, sometimes it'll issue a warning that variables have not been used. Here I'm changing A's X value to 4. And I'm printing out A's X value, and I'm printing out A's Y value. Again, these are called constructors. You can have as many as you like. These are publicly accessible. Why? Because I have the word public turned on. It's a toggle switch. I can turn it off again if I said private. Now everything is now, after the word private, is once again private. Now notice how large things are becoming. We want to start controlling our program. So later, what we will do, well, I'll do something now, is I don't always want to write all the code inside the object because, well, this is all simple inline code. But what if this program to get X and set X, or suppose I wanted to see if 2 points were equal. One more thing. How about a Boolean? 2 points are equal. Is equal. If you give me a point, and we'll call it point P. Give me a point. This is me. I'm a point with my own X, Y, and someone's giving me a new point right here. Well, when am I equal? Well, simply return P dot, well, I can simply say I could get X and compare it to my X, and P dot get Y and compare it to my Y value. And this thing will return true or false if the 2 points are equal. Now, we don't need to do all this? We can simply say point x and point y. Even though x and y are private, notice P is a point. I am a point. I am inside itself. So you don't have to worry about if a point is past another point. You don't have to worry about things being private. You can simply access them this way. Now sometimes the object starts to get too crowded, and I don't want to see the crowds here. So what I can do is cut it out, and for now I can put it at the bottom. And now I have this function called is equal, but I want it to be up here. So up here, I now have this thing called bool is equal. It's a prototype, semicolon. I'm not telling you how it works, but I need to tell you how it works somewhere. We go down to the bottom of the program here. The compiler will be upset because it doesn't know where this thing belongs. So I need to put it inside point. To do that, to place it inside point, you write the word point and put a double colon next to it. And automatically the compiler will say, take this function and insert it inside point. If I compile and run this program, it runs the same way. I'm going to create another point, C. I'll say that's 4, 2. And I'll ask the system if A dot is point A equal to point C. Look how I write that. If point A is equal to point C and the function is equal, accepts as an input parameter a point. And then I'll write something simple here, C out. A equals C. Build and run. And you can see that these 2 points are equal. What are you required to do soon? Well, your first problem is to figure out, to learn all this syntax, to write things properly. Later we'll learn we don't want to put all these function definitions in here. We want to cut this all out, cut them all out, and put them later in another file. So I want to put this inside point. I say point. Now it goes inside point. So I got to tell point what it looks like. Get y. So it knows what get y looks like. I can do for all of these things, every one of these functions it can be done for. I recommend that you do this. Let's copy this program in. Do a screenshot, copy this in on your own. Make sure this works. So I'm still compiling, my program is still functional. So we'll end that now.